In this video, we are going to look at an example where we are going to use implicit differentiation. We are going to use it so that we can find locations of horizontal and vertical tangent lines. All right, so let's recall, if we have a horizontal tangent line, what does that mean? Well, it means the slope of the line is 0. And so, if our slope is 0, that's going to tell us that our derivative is 0. So if we're trying to find horizontal tangent lines, we want to know when is the derivative equal to 0. If we are looking for vertical tangent lines, then our slope, so that line is going straight up and down, so that slope is undefined. So we want to find there, where is the derivative undefined. All right, so we're going to need to go through, find our derivative first. Here is our function, x squared plus y squared minus 3y is equal to 4. So we need to find dy dx. Let's go ahead and go through and start finding our derivative. Derivative of x squared is 2x. The derivative of y squared is 2y dy dx. Derivative of negative 3y is negative 3 dy dx. And on the right-hand side, derivative of 4 is 0. Now, we want to solve this for dy dx. So let's move the 2x to the other side. While I'm doing this, I might also factor out the dy dx on the left-hand side. So we have dy dx times 2y minus 3 is equal to negative 2x. Divide by that 2y minus 3. So dy dx is negative 2x over 2y minus 3. Great. So that is our derivative. So that seems okay. Now, what do we need to do? Now we need to find where are the horizontal tangent lines. So for our horizontal tangent lines, we need dy dx to be equal to 0. So we can say 0 is equal to negative 2x over 2y minus 3. So our x value is going to have to be 0. So there, when our x value is 0, we are going to have a horizontal tangent line. What is the y value when x is 0? Well, when x is 0, we're going to plug this back into the original function. Right? So not into the derivative. We already know the derivative at 0 is 0. That's how we came up with this value of 0, by setting that derivative. So we're plugging this back into the original function. This is an x value, and we're going to try to find the y value. So we'll have 0 squared, which is just 0. So we have y squared minus 3y equals 4. So we're solving this quadratic. So you get it set equal to 0. Y minus 4 times y plus 1 equals 0. So y is equal to 4 or negative 1. And so we have a horizontal tangent at the point 0, 4, and also 0, negative 1. So those are the locations of our horizontal tangent lines. Let's also find our vertical tangent lines. So for the vertical tangent lines, so from our previous page, we saw dy dx was equal to negative 2x plus over 2y minus 3. So we want to know for our vertical tangents, we need to have dy dx is undefined. So when is this negative 2x over 2y minus 3, when is that undefined? It's going to be undefined if we get a 0 in the denominator. So if 2y minus 3 is equal to 0, and that will happen if y is equal to 3/2. So when y is equal to 3/2, this is going to be undefined. What is the value of x when y is equal to 3/2? So we're going to plug this back into the original function. This is a y value. So we have x squared plus 3/2 squared minus 3 times 3/2 is equal to 4. So we have x squared plus 9/4 minus 9/2 is equal to 4. X squared minus 9/4 is equal to 4. And moving the 9/4 to the other side, we have x squared is equal to 25/4. Take the square root. I don't know why I wrote 25/5. 25/4. Take the square root, and we will get 5/2. However, whenever we impose a square root, we should pick up both the positive and negative square root. So we get positive square root, positive 5 over 2. So our points, we will have a vertical tangent at negative 5/2, 3/2, and positive 5/2, 3/2. And there we have found all horizontal and vertical tangent lines. All right. In our next video, we will look at one final example where we do some implicit differentiation. We will see you there.